All right, continuing to work with quadratic approximations. I have a problem for you. I want you to find the quadratic approximation for this function f and have that be for x values near 0. So why don't you pause the video and give this a try. Try to construct the quadratic approximation for this function for x values near 0. All right, assuming that you've given it a go. Again, we're just trying to get more comfortable with making some quadratic approximations. And you can see from the colors here that I wanted you to see that this can be rewritten as a product of two functions. And hopefully these functions should look a little familiar to you. So again, we can rewrite this as e to the negative 3x power times 1 plus x to the negative 1/2 power. So this is a product of two functions. And again, in the last video, we saw that this is the case, that we could find the quadratic approximation in two ways. We could find the quadratic approximation of this product of two functions. And let me not write f. We already have an f down here. Let me write h times g. Quadratic approximation of the product of two functions. Or we saw that we could also take the quadratic approximation of the product of the individual quadratic approximations for these functions. So q of h times q of g. That both methods worked. So maybe we'll do both of them in this video and we'll see that we get the same answer. Okay, so maybe we can start with this left-hand side first. And again, we've already worked with this function before. We made a linear approximation for it a few videos ago. So let's just write out our quadratic approximation formula for x values near 0. So for x near 0, we have that f of x is going to be approximately f of 0 plus f prime of 0 times x plus f double prime of 0 over 2 times x squared. And again, a few videos ago, we found actually, remember, this is just the linear approximation. We found what this was two videos ago. We found that it was 1 minus 7 halves x. And that was a few videos ago. And again, this is for x near 0. And we are approximating f of x. So again, we already found the linear approximation, so all we need to do is find the second derivative evaluated at 0. So let's find that. And we need to first find the first derivative, and then we can take the derivative of that. So first derivative, first things first, we have our first derivative is equal to, well, we're going to be applying the product rule here. So we have, let me just keep it in one color. We have negative 3 times e to the negative 3x power times 1 plus x to the negative 1/2 power plus, now we have e to the negative 3x power times negative 1/2 times 1 plus x to the negative 3/2 power. Again, just applying the product rule and some chain rule. So now that we have the first derivative, we need to differentiate again. And again, you can see when we're taking a second derivative here, we have to apply the product rule twice. So we have to do the product rule for this guy first. So let's do that. So we find our second derivative to be, and we'll switch to orange. So again, product rule of these first guys here, we have 9e to the negative 3x power times 1 plus x to the negative 1/2 power, and then plus negative 3 times e to the negative 3x power times negative 1/2 times 1 plus x to the negative 3/2 power. And that's just for the first guy. So now we have to apply the product rule again for these guys. So we have plus negative 3 times e to the negative 3x power times negative 1/2 times 1 plus x to the negative 3/2 power, and then plus e to the negative 3x power times negative 3/2 times negative 1/2 is 3/4. So we have 3/4 times 1 plus x to the negative 5/2 power. 5/2 power. So that's our second derivative. Again, we had to take the product rule twice. And now we don't have to simplify. We're just trying to figure out what this guy is evaluated at 0. So let's see what we get there. Evaluating this at 0, it looks like we have 9 minus 3 times negative 1/2. And then we have a negative 3 times negative 1/2. And then we also have a 3/4 plus 3/4. Okay, so now all we need to do is kind of simplify these guys and see what we get. So we have, let's switch back to white. This is going to be equal to 9 plus 3/2 plus 3/2 plus 3/4. And it looks like common denominator of 4. So we're going to have 36/4 plus 6/4 plus another 6/4 plus 3/4. And this comes out to, that looks like 15 plus 36. So 51/4. 51/4. And remember, this is just our second derivative evaluated at 0. You don't want to go through all of this work and forget to multiply it by 1/2. So 51/4 times 1/2 is 51/8. So this is going to be plus, oh, I wanted that in green, plus 51/8 times x squared. And that is our quadratic approximation. So that is a perfectly valid way to construct one. And again, that was this left-hand side. And now what I want to do is show us that we could also apply our other method where we know the quadratic approximations for e to the x and 1 plus x to the rth power for x values near 0. That we could also do this right-hand side. So let's work on that next. And again, feel free to pause the video. Try to do that. I mean, we're expecting the same answer here, so you could use your work on this right-hand side to check to see if you got it right. So let's do this right-hand side now. Grab some more space here. Like that. Okay. That's good enough. So again, we'll call this guy H, and we'll call this guy G. We'll call this guy G. Call this guy G. And again, we're finding this is for x near 0, and we know the quadratic approximation. We did this a few videos, the quadratic approximation of e to the x. We found this to be approximately, e to the x is approximately 1 plus x squared over 2. And then if we want to find e to the negative 3x, all we do is replace every x that we see with a negative 3x. So we have 1 plus negative 3x, it's a negative, and then plus this whole quantity, negative 3x squared over 2, and we find this to be 1 minus 3x, and then negative 3x squared is 9x squared, so this is plus 9/2 x squared. So that's q of h here. This is q of h. And now we're going to do a similar thing with 1 plus x to the negative 1/2 power. Because we know from, again, a few videos ago, 1 plus x to the rth power, for x values near 0 is going to be approximately 1 plus r times x plus r times r minus 1 over 2 times x squared. And again, if we want to find 1 plus x to the negative 1/2 power, wherever we see an r, we're just replacing with a negative 1/2. So we have 1 plus negative 1/2 times x plus negative 1/2 times negative 1/2 minus 1. All of that is over 2 times x squared. So cleaning this up, we have 1 minus 1/2 times x, and then this plus this numerator over here is negative 3/2 times negative 1/2, which is 3/4 divided by 2, so that's 3/8. So we have plus 3/8 times x squared. So now that we have both of these, remember this is our quadratic approximation of g. Now that we have both of these, all we need to do is multiply them together and toss out higher order terms. So let's do that. Maybe I could I don't know if we'll have space. I can try to write this down here. Q of H times Q of G. And this is going to be, we're going to multiply 1 minus 3x plus 9 halves x squared, and multiply this by 1 minus 1/2 x, and then plus 3/8 x squared. So again, we're just going to multiply these guys out, toss out higher order terms, and let's see what we get. We're hoping for the same answer. So let's see. We have 1 minus 1/2 x plus 3/8 x squared, and then we have minus 3x plus 3/2 x squared. And then that guy would actually be a cubic term, so we're not going to write it down. It's just going to get tossed out. And then we have our last term, it looks like, is 9/2 x squared. So plus 9/2 x squared. All these other terms here, that's a cubic term, that's a fourth degree term, so those will get tossed out. So all we need to do is simplify. So we have 1 minus, just grouping our linear terms here, negative 1/2 minus 3, that's going to be negative 7/2. So negative 7/2 x. And then our quadratic terms, we have 3/8 plus 3/2 plus 9/2. And all of that is times x squared. So moment of truth here, folks. What is this? What are all these terms added up? We have 3/8, looks like denominator of 8 now. So we have, this is 12/8 plus 36/8. And what does this come out to? 51/8. That's exactly what we wanted. So we find if we were to write this out, so this is 4x near 0, f of x under this method is approximately, well, you could technically write h of x times g of x. We're saying the same thing. So we have f of x is going to be approximately 1 minus 7/2 x plus, we said 51/8 times x squared. And we see that this answer here is exactly what we got up here in green. So we have just shown that both of these methods work. And again, it's kind of up to you in this problem. I found them to take kind of similar amounts of time, especially if you write everything out. So it's up to you in this problem. But the real use of this right-hand side is when you have a really difficult second derivative. So just keep that in mind.